So today I'm actually going to try to make this video very short. There's not a whole lot of information. There's a lot of words to write down, but the concept itself isn't too difficult, and as usual, we will practice it next time in class. We're going to start working with something called VSEPR. I know it doesn't really spell VSEPR, but it's easier to say than VSEPR. So what is VSEPR? Well, it stands for valence, shell, electron, pair, repulsion. Essentially, it's a very simple concept. Electrons don't like to be near each other. So they're going to push away to try to get as far away from possible from each other. And that's going to lead to the different three-dimensional shapes of molecules that we're going to see. VSEPR is always set up with what's happening around one atom. So there's always an atom in the middle. And if we've got something that has a bunch of atoms connected together, well, each time there's one of those that we can view as being in the middle. So what are these electron pairs? Well, electron pairs can either be in bonds, and a double or triple bond is still going to count as one electron pair, or there can be lone pairs. The lone pairs are the unbonded electrons. You'll recall we had those around some atoms when we were drawing Lewis structures, because these Lewis structures will tell us where these electron pairs are. So first we're going to draw the Lewis structure, and then we can figure out its three-dimensional geometry using VSEPR. Well, it can seem a little bit complicated, but actually it's not too complicated because most of you have either taken or are in geometry. So if we have two electron pairs around one central atom, what's the furthest that those electron pairs can be away from each other? The furthest would be on opposite sides of that central atom, which means it's going to have 180 degrees. We call this molecular geometry linear. How about three electron pairs? Well, three electron pairs, the furthest that they can be apart from each other is 120 degrees. This is going to be a geometry called trigonal planar. Four electron pairs. Well, you may be tempted to say 90 degrees, right? Because we take 360 and we divide it by 4 and we get 90. But actually, since we've got three-dimensional space to work in, some of them can go slightly further up, some of them can go slightly further down. So they can be 109.5 degrees apart from each other. This is a geometry called tetrahedral. You can see it over here on the side here. 5 electron pairs will give you a trigonal bipyramidal with 90-degree angle here, 120 there, and a 180 right there. And 6, we're not going to go any higher than 6 around a central atom. It's going to be octahedral, and it's going to have 90s and 180-degree angles. And that's it for molecular geometry. But there's still a little bit more that we have to talk about because these lone electron pairs are going to influence not molecular geometry, but something that we're going to call the shape. Because if the electrons in are lone pairs rather than bonds, the shape is going to be different. Because these lone pairs, you won't be able to see them. They're just electrons. It's not another atom. But they're going to push against everything else, and that's going to influence things. Not only that, but these lone pairs will push against them stronger than the electrons in a bond will be. So that's going to change the angles as well. We'll take a look at that in class tomorrow. But right now, let's just work on the names for these different shapes. So if you have 3 pairs of electrons around a central atom, we saw earlier that geometry is called trigonal planar, and it will still be trigonal planar if you have 3 atoms. But what if you have 1 lone pair? That's going to be a bent geometry. And how will that change the angles between the atoms? As said before, those angles are going to get smaller because these electrons are going to push against it stronger. let's say that you have four pairs of electrons around one central atom. If you've got 3 atoms and 1 lone pair that's trigonal pyramidal, 2 lone pairs is going to give you bent again. And then if you have 5 pairs of electrons, 1 lone pair will give you a shape called seesaw, 2 lone pairs will give you T-shaped, 3 lone pairs will give you linear. We're not going to work with octahedral. Yes, there's different shapes for that too, but we don't need to go that far. In AP Chemistry, they don't go any further than this, so I think we can stop here. I really highly encourage you to get these names down. It will make our discussion in class go so much faster. Also, look up a picture of VSEPR shapes online. That will give you an idea of how some of this is working. In class, though, we will be practicing making some of these shapes using toothpicks and marshmallows. So, try not to eat them all next class, but we will eat some. Thanks for listening.